Hey, how's everybody doing? Thanks for joining the presentation. Chasing the rainbow towards unified service metrics. Is audio okay? Okay, so it's a very long title. My name is Daniel. I live in Copenhagen, Denmark. You can find me on the internet under Dash. And I started working at Zendesk in 2011. So I have an 11-year tenure there, which is sort of part of the background for this presentation, actually. And right now I'm a senior principal engineer working in our infrastructure department. But my background is actually in product development, and I've been doing architecture for a couple of years, but I've spent a lot of time in various incident channels, as probably a lot of you have. And that's another background to this presentation, really. So you can consider this a bit of a decade in review of sorts, which I'm fortunate enough to do because I've been to the same place for more than a decade. This is a bit about Zendesk. It's also founded in Copenhagen, Denmark, actually, 15 years ago. But right now, the headquarters in San Francisco. We got offices all over the world. It's a customer service tool as a software as a service offering. You may have heard of us. I hope you have. Otherwise, we're really cool. And when I joined, we were about 20 engineers. And now we're about 1,500. So that's another sort of part of why I'm doing this presentation, sort of background, that journey from 20 to 1,500 really caused a lot of changes to how we had to do things. So what I'm going to cover today, I'm just going to do like a very extremely brief history of architecture at Zendesk. I wouldn't even call it like architecture, just like an outline of what we've been through. And then a history of observability that sort of has run parallel to that sort of evolution. And then finally, I'm going to talk a bit about service mesh and what's next. I don't know if the service mesh aspect is what got people here. I'm going to talk a bit about that and do a little show and tell. So life used to be simple back when I joined. We had a monolith, and it was pretty great when I started. We had just one code base. It was awesome. And if you needed to figure out why something worked the way it did, you could look at the code. And you could look at tests. You can write a test and just call a thing and call the different components, and it all worked in a single process. It was awesome. If you wondered what was happening when a request was processed, well, each request was handled by a single operating system process on a single machine. You could like SSH in and like tailor logs. And if you wanted to understand performance, like we had dashboards and whatnot, and they were just like focused on one application. So it was pretty simple. But we all know how it goes. We wouldn't be here if we still had just one code base. I think there are companies that have managed to scale with like a monolithic approach to software development, and they really invested in sophistication around having many people work in a single code base. And we did not decide to go down that route. Like we were just running fast to ship features and keep things running. And we never sort of made like a huge effort in sophistication around that. So I think our architecture story is one of evolution and sort of local optimization. And that led to something more like this, a service-oriented architecture. So this is definitely not a microservices architecture. We've never really been a microservices company. We've never tried to break things down into small atoms that talk to each other. But sort of naturally, we evolved towards having more services and more code bases. So why did this happen? It's sort of the old story of just having too many people working on the same thing, stepping on each other's toes. And again, like, some companies manage to write sophistication around that and sort of get through that. It's not something that we, I think, had the resources to do at the time, at least. And even trying to make the situation better by saying refactoring so that you have sort of more modularization became just too hard. Like it was too difficult to sort of change the engine while it was running, while you had hundreds of people committing code. And oftentimes these refactoring sort of petered out or about halfway there and didn't really changed the game for us. And it took forever to run the test suite, right? That's probably also a common thing. Like just every day it got slower. We had more features, more tests, and on, right? If you've ever sort of had a successful application and you've had like a team grow from single digit to like, triple digit number of people working on it, you sort of know that these problems happen very fast and it's very difficult to stay ahead of them. So we slowly evolved towards a new architecture, but of course that helped solve one set of problems, and it just introduced a new set of problems. So now we have many code bases. It's taking us a couple of years, but now we have, I think, 2,000 different code bases. And when you make changes, they're no longer synchronized. It used to be that you could like ship a feature in one code base, like you did the big pull request, you merge it, and that was the feature. But now you have to go to different services, different teams, have to coordinate that stuff, and you can't do like synchronized rollouts. So there's a bunch of stuff that's much harder to do. One of the things that happened that's also sort of key to what I want to talk about today is these cascading effects where you update one service and everything looks fine, but then like an hour later, like someone will DM you like, I think my service on fire, you broke something. And it's difficult to tell because like your service is fine, but you broke some kind of contract or the latency profile shifted a bit, and you don't have like this one dashboard showing the application, right? You have hundreds or thousands of different dashboards used with different teams. And sort of that whole interaction becomes much harder to predict and to observe. And network calls are terrible. So when you have build features and you depend on multiple network calls happening, there's just a host of new issues that you run into, and we started running into those at scale. So it's really an order of magnitude increase in the complexity of the architecture as a whole that we basically chose to evolve towards in order to solve the complexity of having a single code base, right? So each code base is simpler, but the sort of composition of all code bases is extremely complex. And I think that's very typical of sort of large systems. So as we evolved, we had to evolve our approach to observability at each step here. And that's sort of the meat of this presentation actually, is taking a look at sort of what we had to do at various stages. And hopefully it resonates with a lot of folks here who may be at different stages of that journey. So let's go all the way back to the beginning, 2011. I joined, I was young, I was 24 years old, hopeful, and it was pretty easy back then. We had one application, you could look at the logs. So if there was a request, it was just like, top to bottom, this was happened. And we had new Relic APM, which was pretty cool. It's very like oriented towards what's going on in your application, what are the code paths. And what we spent most of our time doing actually was chasing down slow MySQL queries. That was like 80% of our performance issues was like, oh, someone forgot to add an index or something, right? So it was pretty nice, but we grew like crazy, and we had to basically add more sophistication around our observability. So I did a lot of code spelunking for this. It was actually quite fun to look at stuff you did 10 years ago. But this is 2012. We actually started using Datadog for our applications. I think we may have started using it internally for our operations department, which we had back then a bit before this, but I sort of took hold of the tool and was like, yeah, we're going to use this. We can do graphs. It's going to be amazing. So we started sending it over the statsd UDP protocol. It was really cool. It was an unopinionated product initially. I know how many people used Datadog in 2012? Oh, we got a couple, yeah. So I don't know if you can remember, like initially it was just like getting stuff on a dashboard was just amazing. But it's very much like you come up with a metric and you get a graph, but there's sort of a very direct relationship. There's not like, it's not as much a place to build a platform as it is today. So it was mostly metrics. There was also like the events, I think a previous generation of events, but you didn't have tags, right? So it was really difficult to reuse these metrics. We started having multiple services at this point. Specifically, we like split out a couple of big chunks of the original monolith, and we basically just like copy pasted stuff. I was like, well, just prefix your metrics with the name of the application, and do your thing, right? And you could like be inspired by the folks' dashboards, but you had your dashboard and we had their dashboard, right? And as we grew, there was like people just had their dashboards. We had more and more dashboards, right? And we had just custom code to instrument stuff. Like it wasn't standardized, so we just put in some Ruby code, and people would also sort of copy paste that. We tried to like build some libraries, but then folks wanted like an old version of the library, and it was just very tricky to actually get a consistent experience, even knowing how to do that. It was also very focused on the server-side instrumentation, meaning like what's happening in my application. We didn't have a lot of service-to-service communication. Like the way we evolved towards having managed services was we like took a big chunk of our application, like pulled it out, and it received customer traffic. But there weren't a lot of like calls between those. Actually, like the way we sort of delineated how we wanted to make those cuts was how can we avoid having calls between these components, right? So there was some stuff going on, but mainly we didn't have like internal service calls as a rule. Like we try to avoid that at all costs because we didn't really know how to do that reliably. So it's more like a handful of sort of small monoliths now. But we started getting more internal services and pulling actual services out that were just purely internal. And that really started to show the limitations of our sort of application-oriented observability strategy. So back in 2013, we started tracking metrics from the client side, meaning like our code running in the data center, but like the client of an internal service call. And that really allowed us to do a lot more. There were so many problems that are masked when you only look at the server side of things, especially for us because the vast majority of the traffic volume was coming from customer requests. So we were like calling one of the monoliths and doing it as an internal service call, and we had like private APIs and whatnot, but they were served by the same system. And even if you had like 100% error rate, that wouldn't really move the needle in terms of the volume, right? The aggregate error rate for that service was still like nothing, just because the volume of internal versus public traffic was just nothing. But once you look at it from the client side, you say, well, this interaction has a high error rate, right? And that's something we could look at and put on graphs and whatnot. But this was also done inconsistently on like an ad hoc level, and each team that did API calls started instrumenting it and trying to graph it and whatnot. And then something happened in 2013, and it's like weird, but it was actually new back then. Tags. This was amazing. I can't imagine a life without tags now. It's so great. I love tags. But before we didn't have tags, right? There really wasn't a good way to reuse metrics and reuse dashboards. But that changed here, and that really allowed a couple things. Like we now have shared metric keys. So if you could agree that throughput should be like this metric name, and you should use these tags, and then we actually centralize a lot of the tooling, which we just hadn't done before. It was difficult to do. So we could now centralize the tooling. We could have one dashboard, and you can have a tag picker and pick your team or service or something, right? And that sort of started getting us down the road towards actually reusing and having sort of expertise in the accessibility and usability of dashboards and sort of telling us sort of like what's going on in your system. It also allowed us to slice and dice by various dimensions, which is also critical to us. We've always had like, since our start, we've had like a couple of production data centers. Now we have like 14 or something, right? So oftentimes a problem was so present in one. So that ability to sort of slice and dice was pretty crucial for us to be able to actually understand what's going on and where it was going on critically. But we started acquiring companies. We started using new languages, and these different tools we had built like client libraries to do the instrumentation consistently. They weren't quite compatible, and there was like a typo somewhere. Like slowly, these things started to drift. We didn't have like a team dedicated to it because again, we're just like running fast, shipping features, trying to avoid things getting on fire. And so this was sort of happening for a couple of years. I'm going to fast forward to 2017. And nothing really changed aside from the fact that it grew like crazy. It grew like 5x in that period of time, and the problem only sort of got bigger. But in 2017, I committed this. We configured ddtrace, which is Datadog APM's client library in Ruby, probably the same languages. And that's when Datadog APM was released. And this was really the first time we had sort of a good strategy for sort of fully centralizing at least one aspect of our observability. So Datadog APM is an opinionated way to instrument and report key metrics. And that's really what made it different from just the raw metrics product, right? It was awesome. It was cross-language. It was cross-framework. Like thank you all the Datadog folks like went in and instrumented all the different frameworks and language stacks so that things could be mapped to a common set of internal metrics that crucially had like semantic value inside the Datadog product. So they could deliver not just sort of raw metrics saying, oh, this value is now 100, but more like an actionable insight. This thing is on fire, like this deployment is faulty. All the things that actually tell you what's going on, sort of in plain language, is enabled by this sort of semantic understanding of the numbers. And I think that's sort of the final evolution of sort of this aspect of observability, which is sort of the throughput, latency, error rate side of server-side metrics, right? So it's awesome. But our architecture kept becoming more complex. Like it was just like a nonstop march, hockey stick thing, right? More acquisitions, everybody was pumping out services. And what APM did was no longer sort of enough. We had to complement APM with more observability. Specifically, during this time period, we had moved from on-premise hosting, where we just like the way you scaled was you contacted finance and you asked for a server and you waited like 7 weeks and you got the server and you over-provisioned everything because it took 7 weeks to get new capacity. So we always ran at like 2% utilization, right? And the network was just like rock solid and we ran like crazy expensive SSDs. So things just mostly didn't break. Like, and if they broke, like we would just like run around and fix it and then forget that things could break. But that really changed when we moved to Kubernetes and we moved to AWS. Well, first we moved to AWS and then we moved to Kubernetes. Now we got into sort of a whole different world where things weren't static and dependable. They were dynamic and often not so dependable, right? We traded away that sort of stability in order to get dynamism, which sort of cut both ways. We could now like scale very easily. You can, snap your fingers. You got a bunch of new Kubernetes pods, but at the same time, they may be yanked away from you, and like EC2 may like kill your node. There's a bunch of stuff that just happens all the time. And also the network topology became crazy more complex. And generally there was just a category of problems that we just really weren't set up to handle and weren't set up to observe. Some of those are like, we were used to like dealing with like exceptions. That's like the unit of error. Oh, there's an exception and something's wrong, let's fix the exception. But now we had things that weren't exceptions. Like, oh, there's just not enough capacity, or like the thing, the health check isn't working and it's shutting down the nodes, and suddenly like you're calling something and there aren't any instances of the service to handle it, and nothing's showing up in the exception tracker because the request was never actually accepted, right? This happens also like request queuing is a thing that happened where it's like, the request failed because it sat on a queue and then timed out, but it doesn't show up as an exception in the target service. The target service, like error rate 0, great, right? There's a lack of errors, and that's sort of how you determine that nothing's broken. But from the point of view of the client, stuff is broken, right? We have the same like timeouts, like a client-side timeout, like I'm waiting 200 milliseconds, not getting a response, I'm gonna sort of abort that and just fail. And the server side is like, well, I've finished in 250 milliseconds, 200, okay, I'm happy, that's a success, right? But it wasn't according to the client, right? So sort of this mismatch between the server side and the client side for these internal service calls sort of grew larger. And we also like just got sort of new key dimensions that we wanted to understand better. The AWS region is a big one, but the availability zone is something that we've been focused on for the last couple of years. Like we initially did like a lift and shift from our data centers into AWS, and we didn't really think too much about availability zones, right? We was like, we should spread our things over 3 availability zones. But it's only in the last couple of years that we've started really being focused on leveraging the fact that we can have redundancy. And oftentimes, like, you would see the error rate spike for a service, and in reality, it would only be in one AC. So sort of having that as a dimension and saying, oh, actually, error rate is spiking for this service in this AC, that's where you should focus, right? We also started to implement more resilience mechanisms. That's sort of the answer to operating in a less reliable environment, is to build resiliency into your application. So, we implemented circuit breaking and rate limiting and all that. But again, this is stuff that's not really covered by APM. So people started implementing this in a mostly ad hoc way, and then we sort of went through the same journey of trying to build libraries that could do this consistently, but then we had one for each language and they didn't do the same way, and we ended up not being able to have like a global picture. And at the same time, like more services, all the time, more services, new languages, new frameworks, and getting this overview of all the services and how they're performing was just almost impossible. So sort of this continued and brings us to 2019. And our architecture was really complex and it was really hard to reason about, and things were just inconsistent, and that inconsistency meant that we couldn't have this sort of bird's eye view of what was going on. So we took a fateful decision in November of that year. We adopted the service mesh. So like, just a quick disclaimer, you probably don't need a service mesh. Like if you're not like a large application and if you're not having these pain points, then probably it's not worth just the cost of running it, and some of the complexity it introduces, or it adds a bit of latency to our service call. So just want to get that out of the way. This isn't a sort of a silver bullet for everything, but I think once you get to our scale, at this point we probably had something like 1,000 to 2,000 services. It really makes a difference, and I'm going to show some of the niceties you get from it. Specifically, we chose Istio, which I think is the most common service mesh. There are a couple of others. We chose Istio, and I think it's pretty fine. A lot of them use the same sort of underlying system under the hood called Envoy. But I'm not going to get into too many technical details here. But if you don't know what a service mesh is, I'm going to do a very quick primer. Anyone here using Istio already? Couple hands? Okay, so good to do a little primer. So typically, if you have like two services and service A wants to call service B, you open TCP connection, you send an HTTP request, and that's it, right? You get a response. Not so much in a service mesh. In a service mesh, every instance of service A would have an Istio sidecar. So if you're running in Kubernetes, it would be a container running in the same Kubernetes pod as your application container, right? So sort of local to your application. If you're like on a host, an EC2 host, it will run on the EC2 host that your application is deployed to. Whenever you send an outbound request, it goes through this. It gets intercepted and it goes through this proxy that's deployed as a sidecar. And then that proxy in turn calls the service that you intended to call. Except if that service is also in the service mesh, the request will also be intercepted on the destination side of things, and stuff will maybe happen there. So stuff can happen in these two different places. And then in Istio at least, there's a separation between this data plane, the sort of the set of proxies deployed all over, from the control plane. And the control plane pushes information to the data plane, and the data plane is sort of autonomous given the configuration it currently has. You can sort of just keep humming along even if the control plane is down. But the control plane is responsible for sort of shipping updates to the data plane. So that could be like service discovery metadata is a big thing. But like more for our conversation, metrics can be emitted from the proxies. And the nice thing about this setup is that it's a single code base that does this instrumentation. And it can be configured centrally with the control plane, right? So the control plane can push a configuration of the instrumentation to all the proxies. Not quite sort of synchronously, but asynchronously. There'd be dragons. But anyway, this allows us to do sort of completely consistent instrumentation across all languages, across all frameworks, which was sort of a game changer for us. Some of the benefits, like you can do like service authentication and MTLS encryption. There's also a bunch of stuff you can do with authorization. Like we haven't really tapped into a lot of the potential yet. We're only right now sort of finishing the adoption of it, but we've been starting with actually the metric side of things. That's sort of the value lead that we got. And one of the things that we're also working on right now to do more of is using some of the reliability mechanisms inside Istio instead of having each application do it. So that's like circuit breakers and rate limiting. Availability zone affinity is the thing that we're really using a lot to sort of keep traffic within one zone. But it's most of the metrics that we're here for today. So of course, we get the typical metrics, throughput, latency, and errors. But you can actually sort of do more fine-grained analysis of the errors in particular. You can see which ones are timeouts that are enforced by Istio, circuit breaker failures, and a bunch of things that are sort of much more specific and allows you to understand what's actually going on, right? Rather than just like 503. And interestingly, you get these reported twice. So for any one request, you get it reported on the source side, the service doing the call, and the destination side. And oftentimes those will differ. So they're going back to that thing where like your service has no instances. So I guess there are no, error rate is 0, But from the point of view of the source, the error rate is 100%, right? But it'll just say, no upstream instances available, right? And you can see that that's the error that you get. There is just no instances, right? Same with like queuing, a bunch of other things where it's like the server side isn't necessarily in a position to give you an accurate picture of what's going on. It's really the point of view of the client that's most interesting. And also it integrates really well with, say, Kubernetes. So it's very easy to set up based on how you structure things. Like we have sort of a way to categorize different workloads based on like, we have like project and role. And we can sort of set that up to sort of just work by pulling labels off Kubernetes, and you can look at request headers and whatnot. So it's a very simple way to actually get, it's not as flexible as doing things in code in your application, but you can get most of the way there, and it's sort of good enough. And the important thing is that you can really sort of roll this out for everything, which was crucial for us. Okay, so the next part here is the show and tell section. So this is Dash, so I have to show some Datadog screenshots. We built sort of our own centralized tooling on top of this, right? And this sort of goes back to that discussion about like ending up with centralized tooling built on sort of a flexible platform like Kubernetes, sort of Datadog metrics. So this is sort of the top of the line stuff, but we also get more specific things, like we can do breakdowns by service version. We can look at like the network level errors instead of only the application level errors. And this is reported both from the point of view of the source, the client, and the destination. And these will often differ, right? For instance, like circuit breaker errors will show up just on the source, because the source will basically say, hey, you asked me to call this service, but there's a circuit breaker, so I'm just gonna bail like prematurely, right? And that's gonna show up on the source side. But it's still something that the server side people should actually look at, right? Because it's their service that's screwed up. And you can sort of do breakdowns by a lot of these, like availability zone is a big one for us right now. One of the things that I really enjoy doing is like looking at retries and try to like optimize that. Like we just found that our configurations were a bit crazy and would sort of unnecessarily retry. So having just really good visibility into when retries happen, how many retries succeed, how many attempts are made, was pretty crucial. And having that in place for every service was awesome. So you have to actually set this up in Istio for each service. Say, hey, I want to actually have this many retries when folks call me. It's pretty cool that you can define for your service what you want clients of your service to do. So like the source proxies will be informed by configuration on the server side about how to call that server, right? That's pretty awesome in terms of like scaling up an organization, that not every client team needs to like figure out, well, what should the timeout be for this service, right? And rate limiting is also something where we've been able to get a much more accurate picture of what's going on. So skipping through this a bit quickly. One of the things that was really cool, like before, we didn't really know who was calling which services. So if you had a service and you wanted to change an API, you like ask, hey, who's actually calling this endpoint, right? And hopefully people would respond. But then if you made a breaking change, like something would probably break anyway, right? Because someone forgot to raise their hands. But here, because of the authentication thing, you actually know exactly who's calling you, which is also great when you have like 1,000 or 2,000 services. It's just impossible to actually sort of stay ahead of like before we had like people would like register their dependencies manually, right? We had an internal tool for that, but no one would actually keep that up to date. So just automating that was pretty great. So that was the show and tell section. The final part sort of is more about what's next and sort of reflections on this thing. So there is sort of an ongoing effort to standardize the sort of control plane configuration aspect of service mesh, right? So Istio and like linker D or something, what it's called, will be sort of configured through the same mechanism. And I think that's great. One of the things that I'm hoping to have happen is sort of a repeat of what happened with Datadog APM, and I think also Kubernetes. Like I spent a lot of time just doing this, but for Kubernetes. If I'd done this talk like 4 years ago or 5 years ago, it would have been with Kubernetes instead of Istio. Same path. Like we had to like rely on low-level metrics through like an integration. Like these dashboards also powered by an integration that provides the metrics. We don't have to actually instrument the C++ code ourselves, luckily, right? But we had to like build, configure that and build dashboards on top of that data set. And we did that for Kubernetes also, but now Datadog has shipped like a first-party product that, again, has a semantic understanding of what the data means. So that you can provide actionable insights at a much higher level in the stack than I can do in a dashboard or a monitor, right? I hope to see that happen with service mesh in general, like a standardization of the metrics, or what Datadog did with APM, just like going to all the different languages, all the different frameworks, and starting to sort of categorize metrics and instrument things in a consistent way, and then bring that together in a single product that gives you, actionable insights based on a semantic understanding of what the different metrics mean, right? And I think that's really sort of the game changer, where an organization that's very large and diverse can start to get much more value from the same underlying instrumentation. So right now we still have a lot of bespoke setup, and we're probably going to have that for years. I don't think there's anything in the offering right now, but hopefully within a couple of years we're going to sort of get to that point where enough people using service meshes, and there's been an investment in sort of standardizing the instrumentation and the metrics. And that sort of goes to the final slide here. I call it the circle of observability. And I think this sort of captures, the decade I've been, at one place and going through a couple of sort of crucial migrations. Our path to having services instead of just a monolith, adopting Kubernetes, now adopting the service mesh. Oftentimes we start out with a new technology or a new paradigm, and it introduces the need for observability, a need that wasn't there before. And we don't have anyone who shows up with like, oh, I have like an end-to-end solution that just works. We have to drop down to a low-level platform like metrics and solve it ourselves, right? And again, oftentimes it's like first ad hoc, everybody does their own thing, and then we try to standardize a bit, and we try to like enforce standards within an organization. Oftentimes we fail. And then in the end, there's some kind of industry standardization powered by either sort of a consortium or like one company sort of spearheading something, and that sort of provides the off-the-shelf solution that everybody can then use from there on out, right? But that's sort of the cost of being often in the bleeding edge of technology adoption. And it's a really real cost. We have to spend significant energy on this, and if you just sort of wait 10 years, probably it's solved, right? We have the same thing with Kubernetes. Like, we're very early to Kubernetes, and you can definitely feel like things were changing a lot, and we lacked a lot of the sort of great tools and great products that are present now. So that's my thesis, the circle of observability. It all starts over again once you're done. So let's see what the next thing is. That was my presentation. Thanks for being here.
Thank you so much. We have some time. Yeah, we have about 10 minutes or less for questions. Our next session in here is at 5:15, so we have a little bit of time. If you have any questions, come to the aisles. We have mics over there and over here. How was Datadog in 2012? What the UI look like?
It was pretty similar, actually, as far as I remember. It's nice and narrow, but yeah. Hey, Sam.
Hey, thank you so much for your talk. It was great. I was curious about like on the sort of inbound and outbound network call metrics. Or I guess I have a couple questions. One is like, do you ever try to like do math on those metrics at the same time on the sending and receiving end? And like, what does that look like? And also in terms of like your tagging and stuff, I know that high cardinality metrics can be a little bit expensive. Sorry, Datadog. What have you had experience having to like pare that stuff down?
Yeah, good question. So yeah, I've done a bit of comparison between source and destination. It's only recently that we've gotten sort of almost all of our traffic to go through the mesh, actually, because we started out with a lot of the service-to-service traffic, which wasn't the bulk of our traffic, right? That was the ingress traffic. So we only recently migrated the sort of old monolith, which handles like 35,000 requests per second or something, over to use Istio for that traffic, right? And that's when a lot of these comparisons make a lot of sense. But yeah, I do have a graph that sort of shows the diff between the destination reported latency and the source reported latency, right? And that's sort of the network overhead, which is interesting and something I'm definitely interested in, like looking into a bit more, like breaking down network overhead per AC. Also, like looking at like when we do cross-zone traffic versus keep things in intra-zone. Yeah, it's definitely something I want to look more into. But so much fun we can have with these metrics. Cardinality-wise, yeah, it's there's a bit of back and forth with our cloud cost folks on that. I definitely tend to spend more than I'm allowed to. But I also did that like with when tax came out, also just like threw everything in the tag, right? And then it was like, oh, we have like 10 million different values in this tag. We should probably cut that down. I think a couple of times we broke Datadog. Actually had to like suspend ingress because we overused things. So yeah, it's definitely. Oftentimes though, these metrics will replace metrics that are there already that have just as much cardinality. But especially with Kubernetes, like it's very easy to like, we should add this label, and boom, we have like 300,000 new values in your cardinality. Thanks.
Hi, my name is Li from Flatiron Health. I have two questions. One is on the service mesh between the service call. Do you have a cache or queues in between them? Yeah, that's.
If there are queues and caches?
Do you in between the service call, do you have a caching in between, or you just call the?
No, it's only for HTTP and gRPC traffic right now. So in theory, you can use it for all level 4 traffic. So you could do it. I think for that, it would be mostly for like authentication, authorization purposes. And I mean, you could do some TCP metrics if you want to, but we found that it just caused a lot of strain on the proxies. So we didn't really get enough value out of that. Like there's also like MySQL support in Envoy, so you can get some metrics. It just really wasn't worth it in terms of the cost.
Okay. My next question is about circuit breaker. What type of metrics do you collect to observe it?
Great question. I love circuit breakers. So actually, it's really difficult. Like in Istio, like the natively supported metrics are pretty great and work out of the box. But if you want to get some of the underlying Envoy metrics that are not sort of directly supported by Istio, even though the features being instrumented are supported by Istio, that gets real tricky real fast. So there are a couple of different types of circuit breakers in Istio and Envoy. And the ones that are best supported with metrics are the ones that sort of control the concurrency of workflows. So you can say, every instance of a service can support at most, 200 concurrent connections or 200 concurrent requests. Anything above that, you should break that off. There's also like a request queue in the proxy that you can also set a limit on, and once you hit that, it's going to reject that. So that's sort of a destination side circuit breaker mechanism. You can also do that on the source side, like I'm only allowed to call this service with like X number of concurrent requests or something at a time. So those have pretty good metrics, just because like you'll be told in the metric for the request, there's just response flags dimension tag that contains like UO or something, upstream overflowed. So you sort of tell that that request was failed due to the circuit breaker. The coolest circuit breaker though in Envoy is something called outlier detection though. And that's the one we use the most. And that has terrible observability, which frustrates me. And I've been trying to fix it for like 6 months. That's a really cool feature though. Basically, you can configure the number of consecutive errors that any individual instance of a service gives, which then causes the circuit breaker to flip. So if a service is deployed, it has like 100 instances, but one of them is flaky. Then each caller, this is enforced on the caller side in the source proxies, each caller that is calling that and gets like 3 consecutive errors will just like basically like blacklist that one for like 30 seconds or something. You can configure that. And that time will grow, like as it gets back in rotation, it fails again. That's gonna be like 60 seconds and so forth. And that's sort of a really cool mechanism to just isolate bad workloads. It's like the node was bad or something, the network equipment that led to this node was bad. And this just sort of fixes itself. It's amazing, but unfortunately it's difficult to observe. So it's difficult to quantify like how much it really does for us. But in our testing, it's been very effective when configured correctly.
So Istio collects metrics for internal communication between services running in Kubernetes, but you probably don't have everything in Kubernetes. So how do you correlate the data that's collected with Istio with metrics from, like, for example, your AWS resources or, yeah?
Yeah. So I think we typically use like node level tags for that. Which is kind of nice. Like a lot of the metrics, I assume this is the same topology a lot of folks are using here, where you have the Datadog agents deployed like per node as a daemon set or something, and that includes tag set on the node. So those tags will be shared with node level metrics from AWS and whatever else you report through that agent, really, right? So sort of that's a shared unit. It's not always enough, but there's also like oftentimes a set of Kubernetes labels that are used, for all metrics gathered from a specific Kubernetes pod, for instance, that you can use. So this is something that I actually do, like correlating. This is a thing I'm actually looking at right now, correlating like CPU usage with throughput. Like how does CPU usage rise when throughput increases to a specific instance of a service, right? And you can do sort of scatter plot there and see, oh, it sort of follows that or like tape us off. Like, I think that's sort of really interesting to be able to correlate that across different sort of domains. So it's definitely something that's cool. Sometimes it takes a bit of fidgeting with these sort of tags. That's also a thing that's sort of evolved over the years. Like initially, like tags were just like, if 2 metrics didn't have the exact same name for a tag, you couldn't really use them together, right? But now you can actually sort of do with like the $, the value and all of that. So it's more flexible like that. But yeah, you end up spending quite a bit of time like getting it to work, but once it works, you can really sort of unlock some insights, I think.
Okay, great. Thank you all so much. A round of applause for Daniel for a great presentation.
Thank you.